Okay, can you hear me? Turn it up a bit. Thank you very much. All right, so hi everyone. My name is Benedict Chan. Thank you for having me over here. I lead the developer platform at BitGo, the company that launched the world's first multi-sig wallet back in 2013. And we've been hard at work designing APIs and SDKs that many exchanges like Bitstamp and ATM providers like Lamassu use to integrate multi-sig security into their Bitcoin applications. So I first heard about Bitcoin in 2012, and I was fascinated by the implications of the new cryptocurrency and potential uses of the blockchain. So if you can see this, while the old forms of money were controlled by single central bodies, the new models are based upon shared consensus and public ledger. And as opposed to having my identity, balance, and purchases auditable by large companies, with Bitcoin, I could be pseudonymous when making transactions. While before we depended upon law and the trust of banks, now all we need to do is trust in math and cryptographic signatures. And whereas in the past my bank account balances were at the mercy of being moved by humans, now I can write rules and scripts that dictate how tokens in my wallet may be transferred. So I think this is all very interesting. But at the same time, while there's tons of advantages to our new paradigms, there's also new security concerns that we need to think about. So the first one of them, distributed consensus. Well, distributed consensus is very decentralized. It's very fair. And everyone has the opportunity to run their own full node and choose the software and code that governs the rules of their node. But in practice, we kind of trust the miners to keep our network secure. And there are incentives to run large mining pools, as demonstrated in the past by examples like ghash.io, getting very big in presenting some centralization risk. We can also be attacked by entities that have amassed more computing power than half the network. And so solving this problem is non-trivial, but we're going to get through this. Privacy. Well, Bitcoin is pseudonymous, but all transactions are public. It could be possible for anyone to observe the blockchain and figure out individual actions from the public ledger through some simple analysis. And this does add risk for some holders of Bitcoin because large holders could become targets for hackers who want to get a hold of their coins. So we do need to take steps to provide the user with privacy using features like BIP32 HD wallets, for example, which basically say that you don't reuse an address. Once you use one single transaction, you don't reuse it again. This makes it harder to track transactions belonging to a single address. And we also must look into other new concepts, for example, zero cash. Now, what about ownership? Well, we depend upon cryptographic signatures and math, and that's absolute. But the transactions are now irreversible in Bitcoin and other blockchain-based currencies. And this means that we really have to be very, very, very careful about security. As history in Bitcoin has shown, time and time again, high-profile losses in exchanges, they tell us that keys are not easy to secure in practice. So I personally think there's a need to move towards away from single key wallets towards multi-sig, and more importantly, to better educate our users on how to manage their keys securely, both themselves as well as between them and other institutions. Contracts and rules. So for the first time ever, we can write code which specifies conditions as to when and how money can be transferred. However, the challenge here is that because we don't depend on humans and the transactions in these blockchain currencies are irreversible, so we're depending heavily on these rules to describe the business situation beforehand. When there is a difference or like a gap between what is happening in the real world scenario, between what is modeled in our code. For example, if you have a company with multiple directors that should really be controlling a joint account together, but instead they implement their wallet by using a single key that gets in the hands of a low-level employee, then that's when you can run into security issues because the network doesn't understand the requirements of the real world. So during the past couple of years, we've all seen, some security models and multi-sig models, which have emerged. And in the next few minutes, I'd like to share with you some of these emerging models, which we're seeing that people are using to secure coins in institutions and personally. But first, let's go back to the basics, because most of these models use multi-sig. Multi-sig address in Bitcoin is an address that is associated with more than one private key. So in order to spend funds from multi-sig address, you must provide M of n signatures. Now, because the OP check multi-sig script opcode is supported by the blockchain itself, so now we've eliminated the single point of failure when using Bitcoin, which was a single key getting joined up or existing at any point of time. The first ability or first model we look at is that now with multi-sig, we can create and use keys on separate devices with no one device ever holding more than one key. So this means that multiple machines would need to be compromised. You eliminate the single point of failure in the case of malware or hacking, because now the hacker needs to compromise multiple machines. It also gives us redundancy. In the case of, for example, a 2 of 3 multi-sig, you can place your keys in multiple locations on the planet. And if one of the locations is physically under attack, you can still get a hold of the other 2 keys and get the funds. So that's pretty nice. Some of the examples of how you can do this, you can use Bitcoin D, you can use Armory lockboxes, which will help you create multi-sig keys. Now recently, hardware wallets are being developed to work with multi-sig. And the key difference here between a hardware wallet and just a machine which holds a private key is that the hardware wallet actually implements the signing logic on the wallet, such that the private key should never ever leave this hardware wallet. And as we can see, hardware wallets are meant to be more malware-proof than normal PCs, which is safer. Another great use of multi-sig is to put multiple parties in joint control of a single wallet. For example, you can have a family savings wallet. If your family has 4 people, all of them can contribute to a wallet together. You have a 2 or 4 multi-sig wallet, and then 2 of them, they go forth after the money is enough and go and buy a birthday gift or holiday funds together. You can also have a custodial child wallet. For instance, you can model 2 parents and one child in a joint 2 of 3 multi-sig wallet. And when the child wants to go out and spend money on a book, he just has to contact either the mother or the father and co-sign together with them on a wallet. And then you can also kind of model represent some business partnerships here. For instance, again, using a 2 of 3 wallet, if you have 3 business partners, then 2 of 3, well, it does represent the kind of majority quorum on a single wallet. BitPay has come up with CoPay, which is a great multi-sig wallet for these kind of cases. But just used this way, there are some limitations in terms of coordination. One of the things we realized is that with this vanilla multi-sig, all the signers are equally important. So, for instance, if I were to get 2 friends to help me secure my coins in a 2 of 3 multi-sig, then because there are 2 of them in that same wallet, they could collude and make away with my coins without me doing anything, because they have 2 of the 3 keys. Also, pretty much every transaction on this wallet would require human intervention. Multi-Sig Escrow is another nice use of a great model to increase trust and security between participants that have very little prior history. The buyer and the seller, they send funds and collateral into a shared wallet. And then if the buyer receives the item in good order, they just create a payment transaction with the seller. Otherwise, the escrow agent can mediate. So that's great. And with Bitcoin, for the first time ever, the escrow agent can never ever steal the funds, because the escrow agent only ever has one key in this model. Whereas in the past, in traditional banking, you would send your money to the escrow agent who would actually hold the funds under their control. So I think this is very interesting. It's currently still in search of a very successful P2P market to use it, but it needs to be done right, and I think we're going to see that happen sooner or later. Now we're going to look at this concept of a smart co-signing service, which is the actual theory behind BitGo, which is the company that I work in. So the way it works is this. We have 2 keys held by the user and 1 key held by the service. And in this scheme, as you can see here, because the user holds 2 keys of the 3, the user can quite easily prove that he owns both of these keys, and so he owns control of the wallet. And the service only has 1 key, so we can never send a transaction or take control of the funds. So typically, one of the 2 users' keys is designated as a backup key and put into a vault, just for use in emergency cases. And when the user wants to spend funds, they create a transaction and sign it with their other operational key, and then pass it on to the co-signing service. Then the co-signing service can then evaluate a set of rules and apply security policies in an automated fashion. As you can see, some of these rules help security, while other rules can bridge external contracts or external requirements onto Bitcoin. In this approach, the set of rules is no longer limited by the blockchain scripts or the predefined signers when you create a P2HH address. So we're able to describe more real-world scenarios in this model. Well, let's have a look at some of these real models that we're seeing emerge today. Well, enterprise treasury is a simple one. This model is great because you can change the number of approvers at any time, and you can now require external authentication methods such as second-factor auth via phones. So the co-signer can collect all these second-factor authentications of all the users that are preset to be able to spend funds on a wallet. You can also have different levels of logic of permissions on how much can be spent. For example, the low-level employees can spend limited amounts per day, but for larger size transactions, the CEO and CFO can be required to come in and approve these large withdrawals. So this stops hackers, firstly, who steal private keys, because even if the hacker steals the private keys, the co-signer won't sign off on it. More importantly, it stops inside jobs by rogue employees. So if there's one single rogue employee that would in the past have been able to get control of a single key and get away with the funds, well, now you can no longer do that because you require multiple approvals before doing that. Next, this is a very important model to me, the exchange hot wallet, because I believe we need to secure our exchanges to prevent them from getting hacked. The exchange is the simplest model, actually, in the hot wallet model. The exchange maintains a single hot wallet for all deposits and withdrawals. And outgoing withdrawals can be limited per day to a certain amount to minimize risk. Then the co-signer does a callback with each transaction to an accounts database on the exchange. And so the way this works is that it helps when the accounts database is on a separate machine from the machine sending the coins, because the machine sending the coins could be compromised, and the hacker could try to initiate a external send out of the coins. But when we call back to the accounts database, then things won't tally up, so no funds would be lost in that case. This is a pretty quick integration path because many exchanges in the past have already been using a pooled wallet model. And so Bitstamp has been using this model with us, as have some of the other examples you can see. It is really easy to do when in the past they've just been using Bitcoin because we have a very quick on-ramp to simply transition over. Now, the up-and-coming model I'd like to see is this exchange-owned segregated wallet model, where the exchange still owns the keys, but now you have one wallet per exchange user. This allows us to do per-wallet policy granularity, which means we can now limit per user the policies on his wallet. For instance, a certain user might be able to have lower limits than other more trusted users, but more importantly, all withdrawals to external addresses could require two-factor authentication. And so the way this works is that when someone wants to withdraw coins from the exchange, he tells the exchange crafts the transaction. Remember, the exchange still owns the private key in this case, and sends it to BitGo. But BitGo will require that the user send a 2FA to BitGo. And so even in the case where the exchange is hacked, the 2FA wouldn't be able to be hacked by the hacker, since they only can get a hold of the exchange keys, but not the user's 2FAs. And so you really minimize the losses here. It's kind of like multi-institutional security. So transactions in this model to the house wallet are whitelisted. The reason for this is that some exchanges have requirements to be able to settle up limit orders and margin trading. And so in this model, we want to be able to allow the exchange to settle up without requiring the intervention of the user. What about the other model where the user actually owns their own key, which is great, right? The user owns their own private key. And this means that the user is in control of the funds. So this means much less risk in terms of the exchange going down. They won't lose any funds at all. We can have a backup key custodian at arm's length, hold the user's other key. And what this means is that now you can do buy orders directly to the user's wallet, which he does control. And you can even do, so in the buy order case, the exchange holds the fiat, which the user has deposited, and debits the fiat amount and sends the Bitcoin or the cryptocurrency to the user's wallet. But in the sell case, now sell orders can be confirmed by the exchange instantly. And why is this so? It's because the exchange can trust that BitGo, as the co-signer, will never ever double spend any transaction. And neither will the backup arm's length custodian. This is actually pretty great for places that allow you to just buy Bitcoin or sell Bitcoin. For example, places like Coinbase without the exchange. The reason why it doesn't work for margin trading is that in margin trading, you require that at some point the user come back and settle up. And if the user is owning control of their funds and they just forget to come back, then the exchange has funds locked up in this account. And now a final model where the user and exchange both have a private key. Well, the user and exchange both own a private key, and so we can still get instant confirmations for sell orders and buy orders. But the problem is, how do we prevent the user from running away with the funds if he has placed a limit order or a margin, or he needs to pay up for a margin call? And so what we do is we make withdrawals depend on a webhook call to the exchange to ensure the user has sufficient margin. So when the user creates a withdrawal transaction and he sends it to BitGo for co-signing, our co-signer will contact automatically the exchange and ask if the user has any outstanding unsettled amounts. And only if not, then we allow the withdrawal to be processed. This model is pretty good because even if the exchange goes down, then the user still has control of the keys. And it's something like that we'd like to see moving forward. So that's pretty much all of the models that I'll be showing today, but I will also quickly implement a multi-sig secure wallet for you guys in 5 minutes. We've built a suite of open source tools to make it easy for any developer to come and operate any multi-sig wallet, and I'm going to give the demo right now. So all of this code is running live, and all of this is pretty much real coins. I've already logged on here to my account, and now if I want to create a wallet, then what I have to do is first, let me get in the window there. Let's make it bigger. OK, so I create a wallet variable. And then I do bitgo.wallets.create wallet with keychains. And please excuse any typos here. I give it a passphrase to encrypt my user key with. Not recommended to use this passphrase. There's some stuff disappearing. Let me make this clearer. Oh, OK. Well, I was pressing the up button, so don't worry about that. And then I give it the backup xpub. So what this method is going to do is it's going to generate one key on this machine that I'm using here. And this key will only exist on this machine. It will be encrypted. The other key will be generated on BitGo. And finally, I've passed in the backup xpub, which is the public part of the final backup key. So that's 3 keys in total. And now I'm going to say function error result and let wallet equals to result dot wallet. And hope that it works. Let's take a look. I guess it didn't work. Let's do a little quick debugging here. Is the network up? It's not actually getting called into? OK, well, let me start over here. I'm pretty sure it will work this time. I think the connection just got lost. So I'm starting with a fresh node process. Yeah, live demo C. What is wrong with this? The internet doesn't seem to be up. OK, no worries. I will get around this problem. Just give me 1 minute. Stanford is down?
If you go to an HTTP site, then it'll ask you to log in.
Yeah, I just did. It's not.
HTTPS.
Oh, OK.
So I think you need to go to just try another one.
Oh, OK. All right. OK, looks like we are back in business here. OK. Guest network access. All right. Let's get back in business. OK. So start node again. Authenticate. Don't see the password. And I'll just type that again. Ooh, OK. The joy of live demos. Right. All right, OK, we got the wallet object. Woo! OK, so now our next step is simply to create an address for our wallet. It actually gets created with an address, but we can create another one. And all we got to do is wallet.createAddress, like so. And we should be able to view our new address. So here's our new Bitcoin multi-sig address here. And we're going to take this address, and we're going to, I want to display a QR code so that I can put some money in it using my phone. So I'm going to use blockchain.info here. And then I am going to use my phone to send some coin into the wallet. It's too bright. I think I got it this time. I can't because the laptop is not. All right, I'll do it here. Oh. OK, it scanned the QR code. Gonna send some money in. Sending. OK, look, the transaction has been seen on the Bitcoin network. And now we can view this transaction here in the wallet. So easily enough, now you can see the transaction on the wallet. And if you want to look into it a little bit more, you can see that I've sent in, how much is this? This is in Satoshis. So if we divide by 1E8, it's 0.1 Bitcoins. The next step we want to do is we want to actually send some coins over to someone else. And in order to do that, for security purposes, you need to provide your OTP. Of course, this step programmatically can be skipped, but I haven't skipped it on this account. I'm just typing it now. And so that's unlocked. And then sending coins from the wallet is really as simple as doing a wallet.sendCoins. a address and give it a destination address. And amount, so I'm gonna be a little stingy and just give 0.05. You have to provide the amount in Satoshis and the wallet passphrase, which was used to encrypt the wallet. Thanks, guys. Great crowd. And just to be safe, I'd like to output the error as well as the result and hope that everything works. OK, great. So that's a transaction in hex and the transaction hash. It has already been sent out onto the Bitcoin network. So if we go view it, we'll be able to see that it has gone up. So that's pretty much it for implementing the wallet. However, the question to be asked here is, well, what just happened, right? In that case, locally we created half a transaction. We signed it. We sent it to the cosigner for signing. The cosigner accepted the OTP, but then no rules were applied, and so the money just went out. So very quickly, I already have a wallet that I've set up with a limit of 0.1 Bitcoins. And so I'm going to say, get this wallet and load it up here. And say, wallet equals to the result. And then view the wallet. And as you can see, this is a wallet with a lot more money. It's actually got more than one coin in it. Now, as an example, we're going to try and send same 0.05 coins. And this should be allowed. Remember, my limit has been set to 0.1. However, once I try to withdraw more than 0.1 coins, for example, in this case, 1.05, then it will say it exceeds the per transaction limit. And so the cosigner has prevented this transaction from getting out to the network. That's the end of the demo. We're going to finish up right now. OK. So